Voltage divider rule if capacitors are connected. What are the two capacitors C1, C2 and the total voltage is V. If you want to find the voltage across C1, what we need to do? The voltage across C1. If you want, then VC1 is equals to the total voltage V. We take the capacitor of the second capacitor value, we will multiply, not C1 as of we have done in inductor and resistance. If you want the value at resistance or inductor, if you want the voltage, we used to multiply that respect to resistance or the inductor. But in capacitor, what it is, if you want the voltage across this capacitor, we need to multiply the other capacitor value C2 by C1 plus C2. If you want the voltage across C2, the other capacitor value of C2 is what? C1. V into C1 by C1 plus C2. We will see a problem. If a 12 volt is connected 3 farad and 8 farad, if you want the voltage across 3 farad, then the total voltage is 12 volts into the second resistance, the second capacitor what we have, we need to multiply 8 by 8 plus 3. You will get as 8.72 volts. If you want the voltage across 8 farad, then multiply the total voltage into the other capacitor which is present 3 by 8 plus 3, that is 3.27 volts. I hope you understood the difference. For capacitor, we will consider the other capacitor value and we multiply with the total voltage. But whereas in resistor and inductor, what we will do is, we will consider that particular inductor or the resistance value and multiply with the total voltage. But here, if you want the capacitor C1 voltage across C1 capacitor, if you want the total voltage of present at the C1, then VC1 is equal to the total voltage into the other capacitor value C2 by C1 plus C2.